Starting in 2 minutes. Love it.
Okay.
I pull up my slides here. I was getting too talky and I forgot to pull up my slides.
Did you get a chance to try it out on one of the contracts?
Yep. I did one of the smart contracts that you sent over, specifically the origami NFT by Kokyo NFT.
Awesome. Great.
Yeah.
Okay. Let's jump in here.
Perfect.
All right. Hello, everybody. I'm going to start momentarily. Thanks again for joining us.
Hello, everybody.
Right. Let's jump right into it. Thank you once again, Marcus, for coming over. This is your host, Luis, here with Astar Network and presenting another demo day. So we have our guest, Marcus, here from The Graph. And again, thank you once again for joining us. I'm super excited to see the demo, especially with the team, The Graph, who's well known in the space and has a great reputation. So a little bit about yourself, Marcus, a little introduction, perhaps a background, favorite Pokemon or Japanese food, anything really.
Oh, I mean, I just want to go straight to the Japanese food. I was actually in Tokyo a few months back, and I remember having for the first time just rice and eggs and soy sauce on the top. Very simple. And I was just in love. I was like, oh my gosh, it's so simple. It's so healthy. But anyways, that's I think a good place to start. My background, I've been working with Edge and Node for about 1.5 years now. Working dev relations, my job is essentially onboarding and education and instructing developers about subgraphs, how to use subgraphs, and then also understanding the graph as a whole. And then with that, it becomes just how can I best assist developers have a good experience, good DevX, and also getting feedback and doing workshops like this. So Luis, you and I got to chat a few weeks ago on the Graph Builders office hours. So I got to learn about Astar and learn about what you guys are doing. And I appreciate you and your team making the time for me to come over here and chat with you.
Thank you so much, Marcus. I'm a big fan of the rice too, especially it's all about the rice, really. Even in sushi, all about the rice.
I got a Zarushi rice machine. It's the best machine that I got back from Japan. I'm like, I need to get that rice machine. It's incredible. So yeah.
You're one step ahead of me. Oh my gosh, you're brave. I would never try to imitate anything on that side. I would fail.
It's worth it. It's worth getting that rice machine. It's amazing.
Next demo day would be about rice for our guests.
Perfect.
Okay, great. And for some of our newer viewers and builders out there, I think it would be great if you could just jump into a little bit of what the graph is. Like, who's the team? What does this team do? And a little bit about subgraphs as well, as we're doing a demo about it, right?
Yeah. So we could do 2 different ways, whatever you prefer. I can go into the workshop where I'll do an introduction to the graph, or we could just chat about it. What would you prefer? We could just go back and forth, or we can...
Let's do a little bit of a chat and then jump into the demo, so everyone has a good base or context of what we're about to see.
Yeah, you bet. So the graph is an indexing and querying protocol that is really responsible for indexing data on over 50 different chains, as well as off-chain data on IPFS and Arweave. And specific to what we're going to go over today, we're going to be looking at smart contract events. That's really the bread and butter of what the graph is able to index. Now, it's not only indexing it in a way that is performant and reliable, it's doing it in a decentralized way. And so anytime you go ahead and use a subgraph that is on the graph, that subgraph is not being centralized. Essentially, the pipeline to your data is not centralized, such as many other different players in this industry that do have centralized indexing and querying. The graph is not. The entire infrastructure is designed to provide data to data consumers in a way that has decentralization and tokenomic incentivization baked into the protocol that will always lean towards decentralization. And especially over time, we're decentralizing more and more and more of our stack over time, as opposed to some competitors which are centralizing more and more over time.
Awesome. And is that related to the sunrise event we just happened to see?
Great transition. Dude, that was like spot on, host. Yeah, yes. So Sunrise is something that the graph has been pushing towards for 6 years, pretty much since its inception, where initially the graph was centralized and it had to be to actually do a lot of R&D and testing and to actually get this thing off the ground. And so from there, with the long-term goal being decentralization, truly all the way through, and having every indexer that is in its permissionless way indexing data as opposed to a centralized indexing solution, that was Sunrise, literally June 12th, 12 days ago, where we essentially take the hosted service, which was our centralized indexing service, and we shut it down. And so we do not have centralized indexing anymore. We simply have indexers on the graph network. And that is something that we're all very, very excited about. It was quite a celebration for a team working for many years on this.
I just got the chills. You know, we talk about this decentralization, and it's always a buzzword, and I mean, year after year after year, right? And everything moving towards that. Yeah. It's become a meme, but when you actually hear it and actually it's implemented, it's chilling because we all know what that means for. I think many of those crypto, heavy ethos, Web3. So it's great. Congratulations. I think that's good for the whole space, in my opinion.
Yes, it is. It is. And to actually not only have it just be ethically advantageous, its performance is actually advantageous too, where you get more redundancy, you have actually more indexers competing in open market to provide better performance. And that is only provided really by decentralization and having an open market for indexing, as opposed to anything else. It's really cool to see the actual open market working in terms of providing technological advantage.
Wow, amazing, truly.
Yeah.
And I think we should show our viewers a little bit about it. Let's jump into it.
Sure.
Take it right away.
Let's do it. So I'm going to share my screen. Let's see if I can do that. Sharing screen. Okay. Okay. I think we're getting that here.
Yep.
Okay.
And switch over here. And I'm going to leave the whole stage to you now, Marcus. Thank you so much.
Okay, awesome. Well, let's get into really understanding the graph from a high level, and we'll slowly start to go into more and more focus specific to subgraphs and building subgraphs, because I know A-star devs are listening and want to understand, okay, how do we have A-star and the graph kind of worked together? So we'll do that starting at a high level. We'll just go deeper and deeper and deeper. Luis, if there's any questions that you see in the chat, feel free to interrupt because I can't see the chat right now. So yeah, just go ahead and say there's something in the chat and interrupt right in the middle of the presentation. That'd be totally fine. So let's go ahead and start with this. This is the repo that is going to be useful potentially to developers out there that want to just drag and drop the code into their own repo. I wrote this repo just to have code for developers out there who just want to get started building and just querying subgraphs that are already on the graph today, as opposed to building a subgraph and really having to understand, like, okay, how do we actually do data handling? This is simply a repo for not doing that, just simply gathering this code, putting it into your own repo, and querying data that's already just sitting there waiting for you. And that'll make more sense in a little bit, but this is a good repo for you. Let's go ahead and go into the presentation. It is not the answer that enlightens, but the question. One of my favorite emotions is curiosity. It has what has fueled me and pushed me my whole life. And I really think that's the case here, where it's nice having the answers, but the curiosity is what pushes us forward. And I'm really proud to be working with a team that can provide answers to all of your curiosity out there. So let's get into getting curious about the graph. So this is part one. Kind of went over a little bit about it before with Luis. Let's go ahead and go into really understanding the graph a little bit more technically. So the blockchain itself, all blockchains are write optimized, and the indexing of that write optimized data is required, where anyone around the earth can write to any chain, A-star and any of the others, and they are simply the data is put into the blocks in really just timestamp order, whoever pays for the gas and actually gets that transaction in at that time. But it could be from any smart contract on that chain. So within that, it's quite disorganized in the block itself. And with that being said, that disorganization doesn't help with performance. And so you have to index that data. It has to be organized. It has to be provided in a way that it could actually have a good user experience when we want to grab that data and provide it to our users out there. So Not only is indexing required in terms of organization, but there's also reading. How do we not only organize that data, but then provide the answers to the queries that we are sending to that data and have it be performant? Because sometimes a data point is never queried ever, and sometimes a data point goes from 0 queries for years and then has 1 million queries in an hour. And that big spike really has, we have 2 issues here. We have the indexing issue, we have to organize the data, and then prepare for big spikes in performance that really can be challenging too. There's a solution for this out there. There's 2.5 read solutions out there, which has centralized indexing performing this for us. But essentially what you've done is taken the advantages of the security of the blockchain and neutered the ability for it to be decentralized and have really vendor lock-in that we've all been trying to move away from for many years. So the graph essentially takes that centralized indexing solution and breaks up in decentralization, where every one of these little G's, these are a logo right here, are indexers not owned by the graph. These are permissionless indexers like you or me. We could become indexers if we would like, and index and provide queries to Web3 as a whole. And also any devs out there, Web2, Web3, doesn't matter. Whoever wants to send a GraphQL query to the graph, and we are an indexer, anyone out there wants to become an indexer, we can go ahead and become part of the graph and help out this protocol really support Web3 as a whole. So that's really the data layer of Web3. That is a summary, high level of the graph. It has 150 indexers worldwide, each of them their own little businesses, and they all have their own rates and their ability to receive GRT tokenomic incentives. Permissionless, redundant, where any one subgraph can be indexed by multiple indexers. So if one indexer, for whatever reason, loses power, you've got backups. And that's something that I'm really proud to have, where we have that good redundancy. Fast, cheap, and reliable, where we're getting very quick response times on the Graph network, and it's cheap, $40 per million queries, and there's 100,000 queries per month for free. And it's a global open API. Anyone can build on the graph. Anyone can also be incentivized to build on the graph because there are tokenomic advantages to building on the graph. So let's go ahead and go into subgraphs. Before I go into that, Luis, were there any questions that you have, or anything in chat that I can't see right now? We good to go? Okay, taken by the quiet, we're good to go. Let's go ahead and go into part 2, which is understanding subgraphs. We talked about the graph as a whole. What are subgraphs? So subgraphs are customizable APIs that we can customize. We can build them. We can have the specifications of exactly how we want that data coming from our smart contract to be handled and organized. And then also subgraphs are valuable. It's not just a piece of data and something that we build and we just put into our repo and it sits there. It actually is in a marketplace. The second that we publish our subgraph to the Graph network, it enters a marketplace where, if it's valuable and we've built something that is valuable to Web3 as a whole, there's tokenomic incentives that can be returned to the subgraph builder, as well as anyone else that wants to support the subgraph builder's tech. So, and in this stack right here, this visual of all a few different chains here and all the indexers, essentially what we're building is this area of the stack right here, where we are having the indexers get instructions, which is a subgraph, and then those instructions will pipe the data into the front end of whatever decentralized application is out there. So another visual, I think visuals are helpful. This is a good metaphorical visual for what a subgraph is. It simply takes the disorganized data of the blockchain and puts it into nice organized buckets that really assist in performance and really having a good user experience, and making sure that we have really data that is very much at chain head, and then also having that data be really, really accessible and easily queried by GraphQL queries. This is a high level, well, I guess I've written a medium level overview of a subgraphs build and the 3 main files of a subgraph. Essentially, what we do in the manifest, also known as the subgraph.yaml file, is we define high level what the subgraph is doing in general. And we'll go into that in a little bit more. The logic is the mappings file. And this mappings file, sometimes it changes its name from mappings to the names of the smart contract, which is fine. But this is how we handle the data and what we do with the data. Do we do any transformations, addition, subtraction, first, last, all that type of stuff, organization into different entities in the database. That's all done in the logic here. And finally, the organized data is here in the schema.graphql. This is the database right here. So we manifest is we kind of look where we're going on chain, what smart contract are we doing, what start block are we looking at, the logic, we handle that data, and then we finally store it in the database for our queries. And with this presentation in the beginning, we'll be going over this schema.graphql file primarily just because that's the easiest one to assess when we're trying to assess a subgraph's quality, okay? So we'll talk about this in a little bit. This is the Graph Explorer, which has just been updated literally a few weeks ago. So this UI is going to look different. But yes, this is the marketplace we'll be diving into in a second. So once again, this is the Graph Network. Literally a few weeks ago, I gave this presentation, I think it was 2 weeks ago, and I think there was 3,500 subgraphs on the Graph Network, or now it's just known as the Graph. So I guess we could just delete that too. Now there's 6,000. So we just had a big bump just because Sunrise was here. Which is quite exciting. So celebration for us. So let's go ahead. Where are we here? And dive into querying a subgraph that's already built. It's already been organized by a subgraph developer. They already said, hey, we know what smart contract we want to look at. We want to go ahead and send a query and provide the ability for developers to send a query to the subgraph, and we will actually want the subgraph to exist in the marketplace as open data. So we'll go through these steps. We'll set up an API key. We'll find and assess a subgraph on the Graph Explorer. We'll design some queries that we can send to that subgraph. And then if you would like, you guys can integrate the query with a data of your choice. So let's go ahead and start with setting up an API key. So we'll go to thegraph.com and go ahead and go to products and subgraph studio.
Marcus, while we're going through this small transition, we have a couple questions.
Sure, let's do it.
We're currently using the Graph for Neat Raffles. It's an NFT project here on Astar. And however, we noticed that the synchronization process needs improvements as it takes too long to sync the current block with the final one during setup process. Is there anything you could comment on around that?
Yes, it depends how the subgraph is made because subgraphs themselves are customizable instructions. So there's optimizations that a subgraph could have, instead essentially just keeping the subgraph at chain head as much as possible. Is that that's the way I'm understanding this here. So let's go to the docs, and the docs specific to the best practices of subgraph. I wrote these with 10 other team members. We had with so many different options for subgraphs because they're so customizable. But essentially, optimization is a big part of subgraph development, and making sure that you can improve query speed. That's a big one. This one can also potentially have improvements in, it's primarily query speed. I'm sorry, I want to take that back real quick. I'm talking with the core devs about exactly what specific performance metrics we're getting, so I'm trying to run some tests with them. But this one is a good one. Improve indexing and query responsiveness by using derived from. Essentially, if arrays become unmanageably large, it just weighs down the ability of the subgraph to index, because essentially it has to put 2 pieces of data into every array that is not using derived from, and that bloats the subgraph. So the right is the issue, and that's a big one. And then also best practice 3. This one's huge. Improve indexing and query performance. Mostly, I'm seeing indexing performance on this one. You'll get up to 42% improvements in indexing performance with a combination of immutable entities and bytes as IDs. Those are 2 really good ones. And then also, if there's any ETH calls whatsoever in your subgraph, that can really slow down indexing. Literally a single or 1 or 2 ETH calls can slow down indexing of the subgraph significantly. So I take a look at those, and if there's any further problems, please reach out to me. I'm happy to help out.
Awesome, thank you, Marcus. And we have another one, and perhaps you could address it whenever is appropriate. Can you go into the tokenomics of GRT and how that may help developers?
Sure. So just getting, I'll get into that in the process of building a subgraph, because that's going to be directly applicable to subgraph developers and understanding the graph protocol as a whole. But great question.
Perfect.
That sound good?
Sounds good. Take it away.
Cool. So let's go ahead and go back here. We went to Studio. Subgraph Studio. There we go. So we got that. Which we want to restart over. That's what we want. Let's go back to Subgraph Studio. This is where we develop subgraphs, just like a YouTube studio, if you will. And what we want to do is go to API keys, and we can just set up an API key. So star API key. every single month, there's 100,000 free queries that you could use to query the graph. And so if you're learning and trying to test it out, no need for tokens, no need for credit card, just simply hop in and start building. Once you do put a credit card in there, of course, put the spending limit on there and a little bit of a buffer. That's just something, just good practices. Another thing I want to mention is that subgraphs have API keys have security, which should be used. You can authorize an API key to be used only with a specific subgraph, which is nice. And then also authorize only a domain that could actually send queries. So if it's coming from anywhere else, you want to prevent an API key from being drained. Those two pieces of security are quite nice. So we're already done. We set up the API key, and I can just copy it right there. And then what we'll do is we'll go to the Graph Explorer, where we explore the graph. We go ahead and look and see, all right, well, what subgraphs are on the graph network? And as you can see, this has just been updated, which looks really nice. And we can see all of these different subgraphs. Each of these have API endpoints, these endpoints that we can send queries to, and from there get our data back. So let's go ahead and just hop in. Well, first at a high level, let's look at this little number here, 55.4 kGRT. I'll make this a little bigger for the screen. 56.1, 55.4, 50.9. What is that? Essentially, that is the amount of GRT that has been applied to each of these subgraphs to incentivize indexers, who are individuals around the world with some crazy good hardware setup that is indexing data. It incentivizes these indexers to index this subgraph's data. And so let's go ahead and just click on this one. Why not? And we can see a little bit of information about this subgraph, a little bit about the tokenomics and the query fees. We won't get into that too much, but essentially what we can see here is with the amount of GRT on here is 50K GRT or something like that. 10 different indexers are on here. So if any one of these, for whatever reason, happens to have power go out, we have 9 different backups. And that's the unique feature of the graph network, where each of these indexers are essentially businesses to their own right. And you can read about the GRT that they are proposing to their people who want to go ahead and put GRT onto them. There's different ways you can put GRT into an indexer, or you could put GRT into the actual subgraph itself. And there's more learning about the tokenomics within that in terms of the advantages, in terms of incentivized returns that you can get. But that's not really the focus of this. I want to talk to subgraph developers, and we'll get into that in a second. But yeah, this is a subgraph right here, and we could just send a query and get data back and start building into different entities and look into the database right here. And we have the query and response right here. And then here is the endpoint. If we actually want to put this endpoint into our decentralized application, all we have to do is just drop in our API key that we simply just created a second ago into this. And all we do is design some nice queries, test them out, see if we get the data back that we want, and just drop it and send it to this endpoint. And so that's pretty much the graph in terms of really quickly, high level, understanding subgraphs on the graph. We're going to go a little bit deeper now, and we're going to assess the quality of a subgraph, not just based on just kind of high level understanding. We're actually going to go into the code a little bit and see if there's some helpful stuff. So once again, these subgraphs are open source. Anyone can make one. So how do we assess the quality? What has good organized data and is valuable in the marketplace? Well, if there's more GRT on a subgraph, generally speaking, that's going to be, according to the marketplace, more valuable data, because there's more people putting GRT into that subgraph, and the open market will state that, hey, more putting GRT, the more investment into that. Think of it like, where there's just more people looking at that data potentially, and more incentive for indexers to make that data solid. So that's something just to look at a high level. Let's go a little bit deeper. And I want to go into a subgraph that was the first subgraph I ever took a look at many years ago now. What is the crypto punks subgraph. And this is a good time to introduce the concept of Masari. So this is another thing I like to look at in terms of assessing the quality of a subgraph. Is it a Masari subgraph, which we can see that little tag here. It's a little black tag that says Masari. Or is it not a Masari subgraph? All right, so what is a Masari subgraph? We'll go to Masari, subgraphs.masari.io. And here we go. Oh, interesting. This is a new bug. Okay, I'll have to message the Masari team. That is okay. Essentially, the subgraphs, I'll message the team later, The Masari subgraphs are subgraphs organized in a standardized way that has a standardized database. And for developers who are just getting started in databases and try to understand that a little bit better, the advantages of that are if we send a query to a unique database, then we have to design the query specific to that unique database. But if there's standardization among many databases, we could take that one query and send it to many of those databases and get analytics get data from all of those different databases from just one query. And Masari essentially has gone through and created, I think, around 800 subgraphs that are, they have different categories. So as long as a subgraph is in a certain category, it will have a relatively standardized schema. Of course, there's versioning updates where they make small tweaks, but for the most part, if they're in the same category and the versioning is relatively similar, you're gonna have returns that you can send a query to 5, 10, 15, 20 subgraphs all at once and basically assess all of Web3 with one query. And that's a really, really powerful feature to go and see. So that's a Masari subgraph. And so anytime you see that, go ahead and check out the database and see, okay, well, how are they standardizing it and how are they doing that? We're not going to go into that too much. I just want to introduce you guys to the concept of the Masari subgraph. Let's go into a simpler subgraph that really taught me a lot about subgraph development, and then we can go from there. So this subgraph itself is the CryptoPunks subgraph designed by a developer friend of mine. And he developed this subgraph, and let's go ahead and see the quality of this subgraph and see, well, why would this subgraph be a good subgraph to kind of understand and how to query this data? Well, the only thing that any developer really needs to look at and understand when they're going into the data is the schema.graphql file. And that schema.graphql file is hopefully, because these are all open source, hopefully going to be linked right here in the subgraph itself. And this developer did that right here. And we can see the code right in here. And remember I said the schema.graphql file, that's the big one, all right? If you go into the schema.graphql file, you could see the actual database that you're going to be querying. And not only can you see the database, a good subgraph developer will also put in comments. So as we interact with the database, sometimes the name of an entity or the name of a field is a little vague. So we send a query to it, and let's say we just get a number back, and we don't say it has a very odd kind of, not very odd, but a vague name such as, what would be a vague name? Wrapped, or not wrapped, that's relatively simple. What would be an odd name? Let's see. These are all pretty clear names. That's a great job from this developer. Let's just say a name is confusing. All right, let's just say for the sake of this. And we want to understand what that name might mean. Well, this comment right here in just plain English explains to people who want to query a subgraph what this actual field represents. And so that's going to be quite nice for developing, where we don't have to go deeper into the subgraphs code. We can just stay at the database level and not see how the transformations are occurring. If we want to audit the subgraph, we can go deeper and see how the transformations are occurring and check the developer's code to make sure we're actually getting the correct data back from our subgraph. But at the meantime, just seeing if a subgraph has comments is really, really helpful. And some subgraph developers don't put comments in, so that's okay. But any new subgraph developer out there, please put those in. That helps subgraphs on the Graph Network really have developers understand how the data is organized. So let's go ahead. Any questions so far before I keep on going on? Is that all making sense?
It's all making sense. Everything looks good.
Okay, awesome. Let's go back here. And so now let's go ahead and keep on going. We've gone ahead and set up an API key. We've found and assessed a subgraph on the Graph Explorer. Now, let's go ahead and send some queries to the subgraphs playground. Let's see, okay, what data are we getting back? We could actually reference the comments and try to figure that out. And then at the end, if you guys want, we won't go over integrating the query with the data, but that's an option for you guys. So where are we here? All right. Okay. Here we go. Example queries. So the first 10 sales in CryptoPunks history. This is about the part of getting about curiosity. Why would we want to know this? Well, we want to see how it was doing many years ago and see what that looked like. Maybe we also want to see the first 100 sales between the specific time frame. All right, that would be also good. So we can maybe do some analytics and create a dashboard between this time and this time. What are we looking at? And then here, what's the total value of all sales and the total supply and the total number of sales? Well, that would involve some compute, because essentially what we have is in the blockchain, all of this data that's not necessarily organized over a time period. How do we go ahead and gather all that data and then do compute on it? Subgraphs can also do compute within them, which is really, really cool. That wouldn't be possible just by sending a query to a single location and doesn't have an ability to aggregate all this data into some useful, powerful information. So let's go ahead and do this. Let's go ahead and go through first 10 sales. So I believe it's, which tab was this? Nope, nope, nope. Oh no, tab hell. Where are we? There we are. So the first 10 sales. All right, let's go ahead and query. We'll go into this location. And these are all the entities in the database. I'm gonna make this a little bigger so everyone can see. These are all the different entities in the database. And each of these entities has fields where that information is really stored. So we're looking for the first 10 sales. So what do? We just go ahead and literally point and click. If we do an individual sale, every entity must be in the singular in the database, and automatically GraphQL will make a plural version of it, just in case we want to query like the first 10 or first 20 or first 30. If we have a singular, we must provide the exact ID of that singular sale, but we don't want that. We want the first 10 right there. Just point and click. The GraphQL is created. And we want to, let's say we want the ID of the entity. All right, we want to know that. We want to know, let's say, the timestamp, all right, and when this occurred. And then we're going to want to filter a little bit. We're going to order by the timestamp because we're going to want to know, right, well, when. And then the order direction. All right, do you want to do ascending or descending? Well, ascending is great. So there we go. We've got the IDs of the entities and the timestamp, and that was easy. And so we have a query right now that we designed and can send, like I said, to the endpoint of the subgraph in a decentralized way. Anytime you see gateway right here, that means it's actually a decentralized subgraph on the graph, which is quite nice. So that is kind of the walkthrough of how to start playing around with these queries. And you can go back to the schema and take a look and say, all right, well, what do I want? Has this subgraph developer organized this well? What are they doing? Go to the schema, go to the comments, and start thinking creatively. That's a really fun way to okay, how is this data organized from the smart contract? How can I get it back? The next, I think I said 100. I think that was it, 100 between two timestamps. So let's go ahead and keep on playing around. We'll close this query here. And just point and click, very easy. We've got these sales, and we want not the first 10, but the first 100, okay? And first 100 sales, it's always good to have the ID of the actual data point in the actual entity. We could also get more information on this. We could look at the amount of the sale. That's pretty cool. We could look at the type of the sale and, what is the type? We may have to go into the comments to check that out, but that's okay. We can see the timestamp, all of that. Let's go ahead and see the first 100 sales, but there's not any filtering right now. So we can order this by, once again, the timestamp. And then if we want, we could do a little bit of logical operators where the timestamp is greater than or equal to, less than or equal to, and whatever the time, I can't remember the timestamp, of course, in the presentation, but I'll just bring it over here. The timestamp was this one. Let's just say it's whatever's most recent from January 1st, 2019. You just simply drop it in to there it is, into the code right there. So now everything here is timestamp greater than that time, and now we're getting the first 100 back. And we can do more filtering, more logical operators, and start diving deeper and deeper into that smart contract from the actual provenance all the way to today, which is really cool. So that essentially is assessing a subgraph quality, the schema, understanding the database, and then from there, sending a useful query. This presentation I'll link in the chat in a little bit, but I wanted to stop right here and see if there's any questions. This is also a good one. What's the total value of all sales, total supply? Let's just do that really quickly in the contracts. I want to show you that a subgraph can do compute, which is pretty dang cool, as opposed to having to do this in another location in your stack. This is really easy to do compute. You just change a few lines of code in the database and it does it in the database. You actually don't have to do it. You don't change the lines of code in the transformations. You just do it in the database. That's a new feature that just came out recently. It's pretty cool. So Let's do sales. Was it? No, it's contracts. That's right. So we'll go to contracts and let's just say first 10, the ID of the entity itself. We can see total amount traded, all right, total sales. And this is a cool little feature. If you hold your mouse over a field right there, and there is an actual comment in the schema.graphql, a pop-up will occur and it will just show you, hey, that's the little comment right there. So that's a little nice DevX feature. So let's go ahead and get that queried out, and we can see the total sales, total supply, and total amount traded of these two contracts that this subgraph is indexing. So any questions about querying Web3 data with the graph before I go into a few closing comments?
Yeah, Marcus, thanks again. Related, actually, what are some of the most complex queries you have seen and only possible with the graph?
I mean, I've seen queries that go like 100 lines of code, like they're bananas, and that's not necessarily. It can be performant, but queries, I mean, just like anything that involves a request, a GraphQL query and getting that data back, the more complex it is, the more the indexer and the index node that they are gathering data through the database, it's going to be potentially challenging. So there's a whole bunch of GraphQL optimizations out there that you can do. Graph.com docs. I recommend ideally keeping your queries as optimized as possible because it just takes longer to search through the indexing. So let's talk about GraphQL best practices. So there's some best practices in here. If you don't know GraphQL, that's okay. We try to keep it as simple as possible, but understanding how to send queries and how to keep them optimized is a big part of querying subgraphs. But yes, they can be quite hairy and quite beefy, and that's just part of building.
So make sure everyone has their razors with them.
Yeah, exactly. I'm going to share all these links in the chat when I get a second, toward the end, actually. And
perfect. Thank you, Marcus.
Yes. Yep. So any other questions?
No, let's keep going.
Mm-hmm. Awesome. So that was really querying Web3 data with the graph. A few closing comments on this if you want to dive in more. Here's a homework query. I'll share this presentation at the end as well, so you can go through and do these homework queries if you want. And this is also the optimized GraphQL queries. We already just talked about that, querying best practices. If you would like to pipe subgraph data into ML or data analytics, you're likely using Python. And this library right here is designed by Playgrounds. It's a library designed to get you going and have it just stay in Python and keep things nice and clean. So play around with Playgrounds and their library called Subgrounds. And then also, if you are developing subgraphs and you don't necessarily want to develop the front-end UI, DAppLooker has no-code dashboards that are available where you just build a subgraph and point it to DAppLooker, or point DAppLooker at the subgraph, and it will populate dashboards for you, which is really nice. And these are this is not, we don't build these, this is other different protocols, other different teams that are building on the graph, and we just really like what they're doing. So anyways, that's it for this presentation with the takeaways, asking great questions of of your smart contract. That's really, think about it. That's really where the motivation comes to learn subgraph development and thinking, all right, well, if we have all the data from the very beginning of the smart contract till now, what do we want to look at? And how do we want to transform that data? And what's possible? That's really the motivation to dive into subgraph development. And it's intuitive once you understand kind of the high level and medium level and before you even get to the low level. So that's about it. Once again, I'll share that link later. And let's go ahead. Oh, this is a cool one too. So many links. If you want to build a subgraph to index your smart contracts, a great way to start is using Scaffold ETH. And so there's already a library put together for this. But that's another topic that we're actually transitioning to right now. Building a subgraph for a smart contract that, let's say, you as a developer have built. And of course, because you've built that smart contract or your team has, there's not going to be a subgraph built for it. So you're going to have to point a subgraph to that smart contract and then index that smart contract. And that whole process might feel overwhelming, but I promise you it's not. And this is a great workshop to get started with that, the one that I'm doing. And then also this is a great blog that can start you with Scaffold ETH if you'd like. So let's go ahead and take a look at what we're going to be indexing. And let's see, this is the origami NFT by Kokyo NFT origami. Luis, there's a little bit of a story behind this. I remember you telling me. This I'm trying to recall right now. This NFT, are you on the line right here? I'm curious if we could just talk
Yep.
about that real quick. Yeah. Oh,
Yeah,
perfect.
yeah.
Yeah.
So Kokyo NFT is a collaboration between two teams, one being Japan Airlines and another Beyond Club, I believe it was. And so they're, dipping their toes into the NFT scene, what it could do. They also has a real use case, as in you could burn the NFT for the specific reward. It's sake or some other prizes or some other real world products. So yeah, this was an interesting project for sure. Just showcasing what NFTs could do and yeah, and the potential of Web3.
Awesome. Awesome. So with knowing that, wouldn't it be nice if we could get all of this data and have it be not just organized in terms of, these filters that, I don't think there is filtering in here. There's no filtering in here, but we just are presented with data. Well, let's dive in and see who's interacted with the smart contract, who's actually built in different ways. Well, there's a lot of different ways that we can do that. And we're going to do that right now with a subgraph. So we'll go to graph.com. And we'll just take a look and say, all right, we want to index this smart contract. Let's go ahead and do that by going to Subgraph Studio. And we're going to create a subgraph, and we'll call it the A star Kyoko, I believe it's Kyoko. A star Kyoko subgraph. Apologize if I misspelled that. So what we'll need to do as developers is npm or yarn global install the graph CLI. I've already done that in the past. So let's go ahead and open up a iTerm. There it is. Okay. All right, see the desktop. Okay, we'll make this right on the desktop. The next thing we need to do is initialize our subgraph. And so we'll just go ahead and copy and just graph init. And what we're having here are the different protocols that we can go ahead and index on the graph. There's Arweave, which is off-chain data. We can index that, which is pretty dang cool. Any EVM compatible chain that is supported by the graph can also be indexed. That's, I think, right now is 40. I can't remember the exact number, but it's a lot of chains. There's also Near and Cosmos, and then we won't talk about substreams in this presentation. Essentially, subgraphs look at events, and substreams look at much more granular data. So if you need like transaction data and like mempool data, substreams get that data. It's just a little bit more advanced than subgraphs. So we'll start with subgraphs, and if you need more than just event data, take a look at substreams. So we'll do Ethereum. Automatically populates with whatever you put in the CLI earlier. We'll create the directory right here, and then we look for A star, which we have right there. So we'll go ahead and put that in there. What contract address do we want? All right, well, let's find it. Copy and drop it in. So what this will do, as soon as we put this in, is we'll fetch the ABI from whatever block scanner is out there. And sometimes the block scanner itself will fail. And so we just keep on retrying. This is not a CLI issue. This is literally a block scanner. We ping, the 50 plus block scanners out there, and sometimes they don't respond. So it might return, it might not. That's okay if it doesn't, because guess what? If we aren't able to get it and the block scanner is not responding, we can go ahead and find that next data point ourselves, which is pretty easy. The start block, that's what we need, and we put that here. Now, the reason we need to find the start block is, let's say the smart contract was deployed at block 1000, and we put a start block in of 0. And well, that wouldn't make any sense because we're indexing from a point where there's no data. And so it's going to take longer for that subgraph to get through to find the first data point. So let's go ahead and find the actual start block. So we'll go to token transfers, and we'll go to the very first right here. We'll scroll down, and 3 months ago, this was the transaction hash. We can go in and find the block right there. Okay. We'll drop that in here, and it correctly pulled the actual contract name from the subgraph origami, which is great. The important thing is when you build a subgraph, it can index many smart contracts all in one subgraph. And so it's good to have good naming of your contracts in here. So you don't want to have all the same name. Just keep good naming conventions so you can actually connect the subgraph to whatever on chain. So this is the magic here. Index contract events as entities. Essentially, what a subgraph is going to do here is going to take the events that are being emitted from on-chain and put automatic transformations on them and put them into the database. Now, the transformations are literally just passing them into the database. Those transformations are where you can get really creative, but essentially it's just linking whatever the on-chain events are and the database, and they just give them the same name. So if it's a transfer event coming from on-chain, it'll be a transfer entity in the database, and we send the queries to that transfer entity. And we'll go through that in a little bit. So it's scaffolding that connection out for us, putting everything together. Any questions while this is installing and spinning up?
No questions. I just got the image of your the little balls going down the glass. What is that contraption? By the way,
a pachinko machine. It's a
pachinko. Oh, there we go.
A pachinko.
I think our Japanese audience is really familiar with that.
Yeah, so a pachinko machine. So essentially, yeah, right now the transformations, I guess that pachinko machine wouldn't have disorganized lines. It's literally, I guess it's organizing it. But yeah, it is. It's also metaphorical here. But yeah, right now we'll go into the code and you'll see how literally we're passing event data into the database one-to-one, and it's doing it in an organized fashion. So, but then the transformations are where we can get really creative, and we're not going to get super creative today, but just introducing that concept. We're not going to add another contract because we just want this one. And then let's go back to Subgraph Studio, and we need to authenticate our local machine and connect it to this actual dashboard here. And to do that, we simply just copy. Oh, my screen is freezing here. What's going on? Oh, you still there, everybody? Hello?
Yeah, we're good.
Oh, okay. My screen's freezing. That's very interesting. Okay. What we'll want to do is authenticate our local machine. We'll copy pasting this into our terminal. We're not going to do that right now because I've already authenticated in the past. We'll just copy paste and enter the actual subgraph. And then graph codegen and graph build does the type safety. That's codegen that does type safety all throughout. And then building gets the compilation done, which is great. And we can see it's all good and pushed through, which is awesome. Now, before we send this to the graph, because it's still on our local machine, let's go ahead and take a look at what we are doing before we send it. Okay, the three main files that we want to take a look at in order, I guess, from high to low, or I guess not even high to low, is going to be these three files. The subgraph.yaml, which is the manifest that essentially tells the subgraph kind of high level, what are we doing here today? What chain are we on? What's the start block? What's the name of the smart contract? What are the entities and the events we're looking at? Just naming them. That's all this does. Cool feature here. This was just rolled out a few months ago. Prune auto. Essentially, if the database is becoming too big, and we're just having bloat on that database, this prune feature makes pruning that database to a manageable size of our choice is really nice. We could do prune auto or choose a specific amount of blocks that we want to store. That's just a really nice DevX feature that keeps our performance really spot on. So the things that we want to really take a look at here are the entities. As we could see, we have an approval entity, which is a location in our database. And then also, of course, we have an approval event. It's just naming these. This approval event comes from the chain. It triggers this handler called the handle approval handler, which we'll take a look at in a second. And once this is triggered and it goes through, the data passes through the handle approval, it ends up in this entity. And you'll see this pattern the whole way through. Another event occurs, approval for all, comes out from the smart contract, it triggers the handler to file, and guess where it goes? It goes into the approval for all. Let's go ahead and look at that flow, okay? We'll go into the mappings file. It renames it to the name of the smart contract, which is origami.ts. It's in the SRC folder here, as you can see. That's origami.ts. And here it is. We have a handler. This whole thing right here is a handler. And this, generally speaking, is how all handlers are shaped. You initially have a name of a function being actually named. You also have an event being passed into this handler. Remember I said the event triggers the handler? Well, here it is. We're passing it in, and the approval event is the type of the event coming into this handler. From there, we create a new entity in the database. The database says, hey, we're going to create something new. It's going to be a blank slate, but it needs to have an ID. All right, this ID is going to be passed in to here. All right, so this is right now, we have 2 bits of data coming from the event. We have the event's transaction hash, and we're concatenating that transaction hash with the event log index, and that returns a bytes object. This is very performant. It's good to have bytes as the IDs. That's better than string. Makes indexing data much more performant. But we already have quite a random ID, which is just good for just having a good database. And then from there, we'll see how the data is handled. We're just simply putting this equals. We're taking the entity owner, and we're creating the owner right there, and we're just passing in the event owner, the event params owner, the entity approved, event
Marcus,
approved.
sorry, Marcus.
Yes, go for it.
Are you showing code right now? Because I don't think it's
Yes, I am showing code.
Oh, yeah. I don't know if you can refresh the screen.
Oh, no. Okay, well, that's okay. That's okay. What we'll do, I've been showing code for a while. And I'll go back and do it over. That's funny. Let's stop sharing, and I'll share my window right now. It's okay. I think I just shared my tab, and I didn't want to do that. Let's go ahead and share the full screen. That's the issue. Okay. Now we're back in. Thank you for pinging me on that one.
Yeah, no worries.
Okay, so we'll go back to the code. The next things that we need here, we have, okay, let's back up. We have our subgraph.yaml, and this is a file that is the manifest. This is essentially telling the subgraph from a high level what it is to do. It tells us the smart contract, the name of the ABI, the start block, which we put in the CLI, and then it's going to connect the entities. The approval entity is the entity in the database, and then the approval actual event that's coming from the smart contract is triggering a handle approval handler, and then it goes ahead and goes and fills that approval entity. And this is the pattern that we see. An event such as this approval for all comes out of the smart contract. It triggers the handle approval for all handler, and then it populates the database with the entity that has the same name. So that's essentially the flow. As a subgraph developer, you need to know of how the data is being named in the subgraph.yaml, and it does so automatically in spinning up the subgraph. Let's say we want to create a new entity or a new custom event handler. We kind of play around with this back and forth a little bit, and you'll play around with that in the code. Next, let's go ahead and take a look at the handler. How is a handler shaped? This handler right here is the handle approval handler, and this handler is essentially how almost all handlers are built. The handle approval handler accepts an event. It takes this event in, and this is the approval event type. And once this event is passed in, it's triggered. All right, this function is triggered, and we have an entity being created in the database, a brand new entity that's going to store this event's data. So how do we do this? We first need to pass in an ID into the brand new entity. This ID right here is a concatenation, as we see that little method there, between this transaction hash of the event and the event's log index. And that's a nice random ID that's super duper helpful. Now, finally, we take the entity created, and the name is the exact same name as the on-chain event. So we have an owner coming from on-chain. The event params owner is going into the entity on our database. And we're just simply passing in the event data into the database. And then we also get some information that's more just good to have. We have the events block and the block number, the timestamp where this occurred, and also the transaction hash, which triggered this event. So these are the params emitted specifically by the smart contract, and these are the kind of the metadata that comes with every single event that we also gather too. Finally, at the very end, the entity is saved in the database, and then that's it. So that's the shape, for the most part, of any single handler that we're seeing. Let's take a look at the database, specifically this handle approval event. And here we have it. We have the database. We have the ID that we concatenated with that method. We have the owner, approved, and token ID. And as we can see here, it's quite nice that we see exactly what is coming from on-chain, uint 256, address, and it's being stored as a bytes object in our database. And bytes, and big int, because there are some conversions going on to be stored in the database. So this is really it. We have our high-level overview of what's going on and just naming things, which is great. We have the transformations. If we want to put in any type of transformations, we'll talk about details about that, creating aggregation entities, creating different ways of doing mathematics. that can be done in here, and also mathematics can now be done in here, which is pretty cool. Compute can actually be done directly in the database, or at least named in the database. So any questions about these three files before we go on? The manifest, the transformations, as well as the schema.graphql database.
No specific questions to those three. We have a general question,
Sure.
but before that, we do have a new type of camera. I don't know if you're able to see your camera, but now you're about 8 vertical color bars. So I think you have
Oh
to restart your
no!
camera.
Oh, that's hilarious. Okay, it's just a day in the life of developer relations. Let's try again here.
It makes for a more colorful demo.
Oh,
If you
it
can.
does. It really does. Let's stop the screen sharing right now. Or not the screen sharing. That's funny. Okay, let's just go back. I have a little camera.
There we go.
Is that better?
Yes.
Okay,
And
awesome.
to the question of the audience, are
Sure.
there any companies or teams that can build subgraphs for others?
Yes, wonderful question. So there is a DAO called Builders DAO, and I'll pull them up here, buildersdao.tech. And these are contractors for hire. Some of the best subgraph developers I've ever met are in this DAO. And buildersdao.tech is the website. Reach out, tell them what you need. They will give great advice. Some of them I would consider close friends, and they are just good people. So reach out to them, tell them what you need, tell them how you want it built, and they will build it. Absolutely.
That's great. Oh, that's a new one for me.
Yep.
Buildersdao.tech.
Yep.
Okay, I'll put that in the chat as well. Oh, we still don't see your wonderful face, Marcus. So, but
I'm gonna get rid of it. My face does not belong on screen today. That's
okay.
funny.
I'll let you continue. Thank you, Marcus.
Yeah. Let's see. Let's try to enable camera. Okay,
there you go.
That was working. Okay, my goodness, that is funny. All right, let's keep on going. So the next. All right, so we went over the subgraph.yaml, the origami.ts, and the mappings, if you will, and the database. Very nice. Let's go ahead and see what happens when we go ahead and deploy this subgraph. Let's go back to our subgraph studio and graph deploy this subgraph. All right, so we'll be, actually, let's do that in iTerm. I don't like mixing this. There we go. So graph deploy. And this is going to do the graph cogen and graph build. It's going to do the type safety and the compilation automatically every single time. And then we see with the build is completed, it's been deployed, and we see the endpoint. And as we see here, it says api.studio.graph.com. This is centralized in terms of its initial deployment. This is going to be done by the Graph's API itself for development and testing purposes. It's not on the Graph network just yet because we haven't published it to the Graph. It's just meant for us as developing and tweaking and tinkering, which is okay why it's centralized. It's not an actual production. So this is the endpoint that we can use if we'd like. And as you can see, there's no API key here even required. We can go ahead and just start building with it right away. So what does that look like in the front end? There we go. We've got it all the way built through. So the subgraph itself, let's just go through what this looks like in terms of development. This subgraph, like I said, has a development query URL. This is rate limited development meant for testing and tinkering and building more features into our subgraph. And we have versioning control here, version 0.01, 2, 3, as we keep on building. And then we could also select what endpoint we want to query. Do we want to query 0.01, 0.02? We could use this. Or do you just want to do whatever's the latest? And let's say we have multiple endpoints for different subgraphs in here. We could play around with that. That's essentially what we can start doing. Now, when we build our subgraph up to, we add 5 new features and we've tested and we're, a different versioning, let's go ahead and update our subgraph.yaml and pretend like this is a new version. So instead of 4.8, we'll do 4.9, all right, new feature. So we have a new start block. And then we will go ahead and do graph deploy again, version 0.0. Let's make this production, version 1.0, all right? And we will go ahead and create this being sent to the graph. And from there, we will go ahead and IPFS was a little bit slow earlier today, so we'll see if it is being responsive today. The graph is in between, it's like a middleware between so many things. So sometimes if, like I said, if one of the block scanners is not being responsive. We can't get that data back. So just keep on retrying. And sometimes if you're seeing IPFS issues, keep on retrying. That's just part of the nature of it. As we can see here, it's kind of hanging up. So what I'm going to do is get out of this. It won't go. Come on. It's not going. Let's go ahead and do a new window, desktop, and then it was, let's see, list, I believe we have the CD A star. There we go. Clear. All right. So let's go ahead and graph deploy. CD. Yeah, that's correct. Oh, done. Okay, 1.0. Let's hope the demo gods are being kind today in terms of, there we go. That was that quick. So IPFS is being happier, and we have 1.0 already there. So awesome, syncing, ready to go. Let's go ahead and play around in the playground a little bit and see what we're looking at in terms of the data. Right now, there's no entities stored in this subgraph just yet because it's just begun indexing. It's only 32% done. Now, version 0.01, full transparency, what I wanted to do because IPFS was being a little bit finicky today, I kept on trying to deploy with IPFS and it just wasn't. So I did it like 2 hours ago just to make sure we had a subgraph ready to go. And this one's fully indexed, all ready to go. Version, as you could see, 0.01 just took a few seconds earlier in when I spun this up. Version 1.0, because it has to get all the way up to chain heads, can take a little bit longer, which is totally fine. The playing around in the playground, we can start to send queries. There's no entities in here just yet, so let's go to the 0.01 where we can actually start to see entities, and now we can get that data back. So we have that data in there. We could see what's going on. So if you remember before where we had the ability to generate queries and figure out this information, we can go and create some interesting queries. You can think of interesting questions. Go ahead and think of, okay, well, who are all the accounts using this subgraph? Where are all the addresses? How can we find that? Well, let's go to where would the addresses be? Well, all the transfers, we need to know to, from, and the value. So we'll have a lot of addresses there. Let's get the first 1,000. Just so you know, when developing and querying subgraphs, you're limited to 1,000 and in terms of data points that return, unless you use a library such as Graph Client or you use Playgrounds. So if you need a lot of data all at once, they can do polling, which is quite nice. This just a singular query does not have polling unless you have a library on top. So we'll do 1,000 with the ID of the entity, which is always good. We want the to, and let's see, from, and we could do, let's see, get all this. So we get all of these are mints right here. So the from 000. So all of that is coming in. So we could see all of the different twos. That's all we're getting. So if we wanted to have all that data, we could see the ID to and from all these different mints. We could see all of the addresses that this NFT was sent to, which is really, really cool. All right, so lots of mints here. We have a transfer. We could see one person sold theirs, and we could see the token ID, see exactly what token it was, see the block number, block timestamp, when it was, the transaction hash. For whatever reason, the smart contract developer decided to not put in the value of the transfer, but that's their choice. That's totally fine. But yeah, we can get that data back, and we can start to see what transaction hash it is. We could actually do a lot of things here. So that is subgraph development. That's a really quick start into it. There's so many things that we could do with subgraph development. I know we're dealing with NFTs, so I do want to go into a little bit of specific education to NFTs and the NFTs metadata that's being stored on IPFS, unless there's more questions about subgraph development, which I'm happy to go into as well.
A quick question, a way to export that data as CSV.
Yes. So with this is really a test environment where you're just tinkering. I mean, of course, you could do a copy paste and write in here and just drop. I mean, I just do Control A, Control C, drop it in somewhere. That's the easiest way to get this data back. In terms of programmatically getting this data and having it saying, all right, well, I need to be able to bring it in. You could write a quick little script and convert to CSV and just simply query the endpoint, which is right under details. So yeah, design, for some reason my screen is freezing a little bit today. But anyways, you can design your query, send it to the developer endpoint right over here, and just write a little script and convert it to CSV if you'd like, or just copy paste the return from the playground.
Awesome. Thanks.
Yep. But anyways, yes. Let's say, remember I said, hey, we have I wanted to bring this through here. This is all a development environment. Remember, we are all just developing here. This is rate limited just for one to, whatever how big our team is to just kind of tinker with, which is awesome. When we want to expose our subgraph to the graph as a whole and have it be public and have it be indexed, not just by the centralized indexer out there, but to have that's run by Edge and Node just for development testing purposes. What if we want to have indexers out there all take a look at our subgraph and all decide, hey, maybe this subgraph is valuable because, well, there's some GRT applied to it. I'm incentivized to index the subgraph. Once I claim the subgraph, I have to index it. So I'm going to go ahead and take a look at the subgraph that's public, and I want to get paid as an indexer. Well, let's go ahead and index that subgraph. What we can do is click on publish. And what this does is this publishes it to the graph network. This makes this subgraph public to all indexers. The public can see it, all of that, which is awesome. Right now, ZK EVM main is partially supported. So only one indexer will hop on this one right now. When it is fully supported, which should be in the coming months, the publication of this subgraph will allow for more GRT to be applied to it. And that's where incentivization can really occur, where there's more than one indexer can hop in. I'm just walking you guys through this right now, where the integration is still ongoing. When you do want more better quality of service, more redundancy, faster query responsiveness, better indexing, what you're going to want to do is publish to the graph network and incentivize with GRT so indexers can all hop in. So any questions about that before I shift over to NFT concepts specific to developing subgraphs?
Looks like it's all clear.
Awesome. Thank you so much, Luis. So let's talk about, I just want to bring up start to subgraph development querying. I pulled this up. We go into a lot of detail here, but what I really want to do is go through these slides right here. So general pattern for NFT entities. So we already have entities in our database that are pre-built. They essentially copy the event data from the chain and bring it right into our database one-to-one. And it's queryable, it's indexed, and it's organized, which is already a huge advantage. Just boilerplate. We don't have to do many modifications. But if we want to do some modifications, that would be nice, excuse me, would be to create a contract entity and look at the actual contract that these events are coming from. Represents the entire collection and what the contract is, what's the address we have, the counts, what's the token count, how many actual token IDs do we have, the owners. This is a good entity to create in our database. How would we do that? Well, let's go to our subgraph and take a look and say, well, we're going to create a contract entity. All right. Awesome. All right, so we've got a contract entity. We're gonna have to create an event handler, custom event handler. All right, so contract, and we're gonna have to go through and find the event signature and say, what do we want to get in here? And we're definitely going to have an address. That's definitely going to be coming out. We'll, see that in there. And let's just say right now we just want the address, but there's other things potentially coming that we could look at that we could throw in. But we just have that in there. And then, of course, what we're going to say is, well, once that event is emitted, we're going to want to create a handler, which ChatGPT is doing a very good job in understanding. This triggers the handle contract. So from here, we'll say, well, when that data comes in, what do we need to do? We need to create a handler. So we'll do export function handle. There we go, handle contract. And so we have this all in here. We have an entity created. We get the new entity. We just save it. And what we're going to want to pull in from here is actually entity.address, and we have the event params.contract. We're actually getting that coming in. So that's pretty easy. All right, just simply putting those lines of code in there. We're going to need to do graph code gen and graph build to make sure. Do we have it in here list? Yes, that's correct. So graph code gen to make sure our type safety fixes up. Yeah, so we don't even have this event signature. It's not even present in the ABI because it's, of course, not in the smart contract, but I'm just kind of going through this for just teaching purposes. Of course, once it's in the actual ABI, and we actually have that built, then from there, this will work because there's no API information in there. But that's essentially the flow. Have that smart contract coming in there, have that in the ABI, and then from there we have that actual flow. And then from there we could actually populate this new bit here, type contract entity. This is the immutable. This would probably be best if it was immutable, because what that means is this indexing will be much more performant. Every single entity that is immutable, that means this entity won't change in future versionings. That would be ideal. So just because we're getting a record of the contract, I think that makes the most sense. And then from here, we'll have the ID, pretty much fill that through, pretty much at one-to-one, that'll be bytes. And then we have the address, which will be of the type address. Okay, so, and that'll also be required. So that is essentially how we create custom entities and we store them in our database. Custom subgraph handlers and go into our database. So are there any questions about kind of that workflow of how we can create a general pattern for any of these custom ways of handling things? There's account entities that would be good, understanding all the different accounts and putting all of the different entities in all the different fields, maybe doing passing into different entities. You could pass from one to the other. The NFT one I do want to talk about briefly, because we can go and get the URI of the metadata and actually index that and index the JSON, which is really cool. We can actually dive into IPFS, which is one level deeper. No questions? Feeling good?
No questions. Keep going. That's
awesome.
Great.
So NFT, this is having metadata and having that URI is really a big part of NFT data storage, just because storing a full complex SVG or a JPEG on chain would be just obscene in terms of costs, at least for many chains. So what a lot of teams will do is store the actual physical image on IPFS or Arweave or some other off-chain location and just simply store the URI on-chain, which is much cheaper. And so, well, wouldn't it be nice if we could dive into the metadata and that JSON that's being stored on IPFS or Arweave and go ahead and grab that and index it? Well, we can. Another feature of the graph is and subgraphs is the ability to use what is called file data sources, which we're able to dive into the JSON itself and go ahead and do indexing of a file stored off-chain, which is really, really powerful. So I wrote this February, came out earlier this year. This is quite a detailed blog post, but I wanted to go over kind of a subgraph developer's thought process as they run into problems along the way, which are just natural problems of like solutions and like thinking of different ways to get through. And I also index data that's both on IPFS and Arweave with one subgraph, which is really, really cool. So go ahead and go check out this blog if you would like to understand how to dive into that IPFS or Arweave data, and also maybe create some really cool dashboards or analytics based on NFTs that, let's say you want to know more about the traits of a certain NFT, more qualities about it. Absolutely. Dive in and really do some analytics on it and see who's the most popular and why. And it's a really cool kind of feature. It's available for all subgraphs, but of course not required to use. So with that being said, let me go back to the presentation to see if I forgot anything, because it is possible I forgot something. Let's see, we did briefly talk about mutable entities, that this is really helpful with if you have a database entry that's going in and you know you're not going to change it. That's a really big deal. And so just leave it immutable and you won't change it, and that's going to make indexing faster. Aggregation, this is when you're taking information from lots of different places and bringing into one location. So contract would be a good aggregation entity. Linking entities, one-to-many relationships, many-to-many relationships. This is where derived from really takes charge in optimizing a subgraph. If you're going to be linking entities, check out the derived from feature right there, which really helps with performance. And then we have, if my computer wouldn't freeze, there we go, get or create helpers. A lot of times in databases and working with entities, if there's already a entity in the database, you don't want to create a double. So you want to get it or create it if it doesn't exist. So creating helpers is really helpful to just make sure your database is done nicely. And other tips and tricks, if you do have control of the smart contract, that's really awesome. Make sure you event all relevant data in the events. If you're not emitting that event data, your subgraph won't be able to gather that data. So go ahead and emit that data accurately, and that's going to be quite helpful. A few other points. I did say file data sources is great. Avoid ETH calls if you can. Essentially, making a call using an ETH call, you're calling a node to get that data back, and the subgraph has to pause to wait for that data to come back. There's a few different ways to optimize this, but ideally just don't use them. If you don't have to, just use events. That's the most optimized by far. And then linking the entities together, that makes a very nice subgraph, truly. And that's basically the entire presentation of playing with this. So once again, workshop takeaways, understand kind of how events work and how they could pass into a subgraph. And that's a really big one. And then also I would use scaffold ETH 2 and the graph. And if you really want to learn the next steps, I would compare a starter subgraph, kind of like the one that we built, and see what that looks like. And then look at a more advanced subgraph and see one that's on the graph itself and published on the graph, and say, what did they do? Is their code open source? Why are they doing things? And then look at your starter and kind of see how they extend it, and just pick one event and see how that thing passes through your subgraph. If you literally trace one event and look at what they're doing, things will start to just click. And that's really, really helpful. So that is it for this workshop. I will be sharing lots of links right here in a second. But for now, I'm going to stop sharing my screen. I'm going to join y'all back in the video.
Thank you so much, Marcus. That was a wonderful presentation. We'll be sure to link everything on our X account and on YouTube there to make sure everyone got it, especially that last article. I think, what was the title of it?
I'm just going to be dropping lots of links.
File data sources, yeah.
Oh, file data sources, yes.
Yes.
Let's see, subgraph best practices. These are optimization techniques that are really helpful for subgraph developers. If anyone is noticing, like, hey, man, I wish the subgraph was more at chain head, or my query responsiveness is slow, what I would recommend is just double checking that your subgraph is optimized. Just because if you're telling the indexer to potentially do some things that are not optimal, well, they have to do it because they're an indexer. They listen to you and they'll do it. But those are really important. This is the querying best practices that I'd like to put in here. And then, of course, what I want to do is share the two repos that I went through today. The repos that were responsible for the subgraph development one that we did. We didn't really dive into a lot of that presentation because I knew there were a lot of builders here. I just went right into the code and we started building right away, which I think was great. But if you want to go into this workshop, that's totally fine too. And the file data sources one, of course. Let's see, subgraph dev quick start. And then this, and then the querying of subgraphs. Subgraph querying Web3 data with the graph. This next one is querying subgraphs that are already existing on the graph network, which we went over in the beginning. And also, of course, file data sources. This one is the one where we can dive into the metadata. File data sources. I think that is everything. I'm sure I could share more things, but let's just.
That's great. Marcus, I did want to touch upon, to round off this great demo day with the graph and you. Some of the non-Web3 developers that may be watching or tuning in later on, whether on YouTube or X, what would you say? A little bit of context, since we're seeing enterprises join in, and may or may not have developer teams or engineers really comfortable with or having experiences with blockchain and everything that we know exists here. Well, what would you say? Why would a Web2 developer jump into this if they're looking for a career, or at least extend their capabilities?
Yeah, I mean, okay, let's go from practicality to
Hmm.
eventually aspirational talk. Practicality, Web3 is catching up quickly to the quality of the tech that is in the Web2 and kind of the ability of just a better DevX. I mean, DevX is not great in Web3 compared to Web2, but it's catching up. And I can tell you very, very confidently that with the quality of teams that I've met, the developer experience is just going to be better and better as the years go on. So if you look at it right now and you're like, it's not quite for me, I get it. It's not the best right now, but it's getting better fast. I mean, I've been with this team for a year and a half, and in just the year and a half I've been here, it has just very much focused on DevX quality. And then number two, in terms of practicality, costs. We understand that costs can be an issue as a Web2 dev looking at Web3 and being like, all right, well, why do we need to do this when we could actually have it more not deal with tokens? A lot of Web3 protocols, such as the Graph, are doing our very best to standardize costs across the board, which we do. It's $40 per million queries if you're using us. So you don't have to worry about the tokenomics going up or down or anything like that. It just keeps things nice and clean and easy. You can even pay with a credit card. You don't even have to pay with GRT. So if you don't even touch the tokens, you could still use the Graph, which is really powerful. So just practicality of the development and then also the practicality of the costs. That's where Web3 is heading as a whole. And then aspirationally, I think, my gosh, I mean, if you want to continue the juggernaut that is Web2, be my guest. That's fair. I mean, there's reasons to stay within that space. I personally choose to not, and I'm very proud to be working in the Web3 industry and working hard to do something different and do something with a value set that gives a chance for a new internet to grow. And so I'm here for that chance.
Thank you so much. I think I started tearing up just slightly. No, really, I do feel
Let's
like
do
that's
it.
some of the words that we need to hear sometimes, especially for those that are going to be seeing, the terminology Web3 or blockchain
Sure.
more and more, right? And so giving them that heads up, or at least, the consideration to, hey, check this out, is important for definitely for our team here at Astar. Marcus, really, I appreciate your time. I really do. Thanks for the great tutorial. I can't believe we have it now. So nice and shiny.
It's here. It's ready to go.
Yes. I'm sure if there's any more questions, please feel free, community, to lay them out in Twitter or on YouTube, and I'll send them towards Marcus's way. Any last words, Marcus?
If you want to have any questions, let me just put my X in here, my Twitter. Feel free to reach out to me on Twitter, on X. I'm more than happy to assist. We have a vibrant community in our Discord. Please join if you have questions. There are thousands of developers in there, and we're trying to be helpful. We're trying to all move in the same direction in terms of Web3. Really making this thing really compete with the Web2 entities out there. So join in, and we're happy to help. And also, if you have any questions about subgraphs and you want a custom one, and don't want to get into subgraphs at all, go to buildersDAO.tech. They'll build one for you. Yeah.
Awesome. Thank you so much. And good luck with the rice cooker, Marcus.
It is the best rice cooker. It is amazing.
Oh, you already, okay.
Yes, I have it. I got it a while ago. It's called the Zarushi Neuro Fuzzy. That's what it's called. The Zarushi Neuro Fuzzy. Highly recommended. It's amazing.
I'm gonna check with my teammates to make sure it's a good one too.
It's amazing. I love it.
Okay, perfect. Marcus, thanks again, and have a pleasant day.
All right, take care. Thanks for having me.
Okay, you too. Bye-bye.